Class 11th topic, motion in a vertical circle. It is a very important topic which comes under dynamics of circular motion, and students find it a little bit difficult. But I hope after watching this video your feelings will change. So let's start with the topic. For this, we'll consider a particle of mass m tied to a massless inextensible string at one end and let it be suspended in a vertical plane from a fixed point O. Now right now this particle is in equilibrium. And what do we mean by that? It means that the net force acting on this particle is 0. And what are the forces acting on this particle? It has tension acting in the upward direction and weight acting in the downward direction. So we can say T is equal to mg. Now let us give a horizontal velocity v1 to this particle such that it start moving in a vertical plane of radius r. Now if you see this figure, the particle is given an initial velocity v1 at point A such that it start following a vertical circle of radius r, which is equal to the length of the string. Now this motion is a case of non-uniform circular motion. And how can we say that? Because the velocity is changing its magnitude as well as direction. Now during its upward journey, that is from A to B and then to C, the speed of the particle decreases continuously. Why? It is because of the work done against the gravity. However, during its downward journey, that is from C to D and then to A, the speed of the particle is increasing due to the work done by the gravity. Now to understand the basic characteristics of this motion, we'll find the velocity and tension at various positions during its motion. For this, let us consider that at any instant t, the particle is at point P where the string makes an angle theta with the vertical line OA. Now, at this particular position, the forces which are acting on this particle are number 1, tension T which is acting along PO and the weight mg which is acting. Now the weight can be resolved into two components, that is one along the tangent component and the other along the radius. So this is theta, so this component becomes mg cos theta and this component is your mg sin theta. Now here we have to understand one thing. Since a particle is following a circular path, so there must be centripetal force. And as we know that centripetal force itself is not a force. Some force will be acting as the centripetal force. So let us find out the force acting towards the center at point P. So you can see at point P along the radius there are two forces. One is your tension and the other is mg cos theta. So what is the net force acting towards the center? So the net force acting towards the center is given by T minus mg cos theta. And this is the force which will provide the necessary centripetal force. Hence, we can equate it to mv square by r, where v is the velocity at point P. So you can mark this velocity. It will be acting along the tangent to the circle at point P. Now from here we can get the value of tension. Tension T can be written as mv square upon r plus mg cos theta. So we can mark this as equation number 1. Okay. Now to find out the value of velocity, we will use law of conservation of energy. For that, let us consider this lowest point A as the reference level for potential energy. That means let us assume that at point A the gravitational potential energy is 0. So applying law of conservation of energy at point A and at point B, we know that the total energy remains constant. So the total energy at point A should be equal to total energy at point. So energy at point A, if we see, now at point A, the velocity, if you remember, we have taken the initial velocity as v1. So at point A, the kinetic energy is given by half m v1 square. However, the potential energy will be 0 as we have taken A as the reference point. And at point P, the kinetic energy will be half m v square plus potential energy will be mgh, where h is the height of point P from the reference level A. Now, if this is your h, now if I assume this as point Q, so can I say that h is equal to AQ, which I can write as OA minus OQ. Okay, and what is your OA? OA is nothing but the radius of the circle, and OQ we can find out from the right triangle OQP. Now if you see this figure, from in right triangle OQP, in right triangle OQP, can I say OQ upon OP is equal to cos theta, or you can say OQ is nothing but OP cos theta, or you can also write it as r cos theta because OP is also the radius. So therefore, since OQ is equal to r cos theta, so if I put the value of OQ in this equation, my h will be equal to r minus r cos theta. Now coming back to this total energy equation, now if I want to find out velocity v at point P, how can we find out? V square will be equal to v1 square minus 2gh. How do I get that? You can cancel m and you can multiply this equation by 2 and rearrange the terms. Now if I put the value of h here, the velocity v will come out to be v1 square minus 2g into r minus r cos theta. So if you open this, this will be equal to v1 square minus 2gr plus 2gr cos theta. So we can mark this as equation number 2 and this as equation number 3. So this gives the velocity in terms of height and this gives the velocity at point P in terms of theta. Now we can put this value of velocity in the expression of tension, that is in equation 1. So your tension will be equal to m by r. Instead of v square, I will write v1 square minus 2gr plus 2gr cos theta plus mg cos theta. Now we can open this bracket. So after substituting the values, we get this expression. Now we can rearrange the terms and what do we get? mv1 square by r minus 2mg plus 3mg cos theta. Now here you can see all these values are known to you except theta. So we can say that this equation gives the value of tension as a function of theta. We can mark this equation as 4. Now we have the value of velocity as well as tension. Now let us try to find out using these expression the value of t and v at various points. We can start with lowest position. Now at lowest position, that means at point A. Now at point A, what will be the value of theta? Theta will be equal to 0. And let us say if we call the tension T at this point as TA, then put the value of theta equal to 0 in equation number 4. Let's see what do we get. As we put the value of theta as 0, we know that cos 0 is 1. So this term becomes 3 mg. So the tension at point A is nothing but mv1 square upon r plus mg. So you can mark this equation as 5. So this gives you the value of tension at the lowest point. Now let's find the value of tension at point B. Now at point B, the string is in horizontal position for a moment. So theta in this case will be equal to 90 degree. So if I put the value of theta as 90 in the expression for tension, let's see what do we get. So tension at point B will be equal to mv1 square by r minus 2 mg, because we know that cos 90 is 0, so we won't be getting anything from third term. So this is the value of tension at point B. Now let us find out the tension at point C, that is at the highest point. Now at point C, your theta becomes 180 degree. Now putting the value of theta as 180 degree in the expression for tension, let's see what do we get. mv1 square by r minus 2 mg. Now cos 180 degree is minus 1. So this term will become minus 3 mg. So at highest point, your tension will be equal to mv1 square by r minus 5 mg. So let's mark this equation as equation number 6. So let's mark this equation as equation number 6 and this one as 7. Now if you want to calculate the difference in the tension at highest and lowest point, we can do that. So the change in tension in the string of the particle as it goes from point A to point C. So the difference comes out to be 6 mg. So what we can conclude from this particular topic? Number 1, the tension in the string is maximum at the lowest point and the tension in the string is minimum at the highest point. Now if you see the third point, since the tension is minimum at the highest point, now if you take the minimum value of tension, now from the expression for tension at the highest point, we can see that this tension can be positive, negative or 0 depending upon the value of V1. Okay, so negative tension means what? Negative tension means the string will slack and the particle will fall down before completing its circular path. So we can say that the minimum value of tension for completing the vertical circle should be 0 at the highest point. So if you put this minimum value as 0, so what do we get? We get the minimum velocity with which the particle should be launched at the lowest point. So you can see when you equate this tension at highest point to 0, we get the initial velocity, that is the velocity at the lowest point, as equal to under root of 5 gr. So what does it indicate? It says that if you want the particle to complete the vertical circle, it should have a minimum of under root of 5 gr velocity at the lowest point. And substituting this value of V1 in the expression for velocity, we can get the value of velocity at the highest point at that moment. So if you just put the velocity at highest point, we know that the height will be equal to 2r. So at the highest point, this velocity should be the minimum velocity for completing the vertical circle should be under root of gr. So in the end, we can say that if your velocity at the lowest point is greater than or equal to under root of 5gr, where r is the length of the string, then only your particle will complete full circular